do is I want you to just go ahead and multiply these two numbers out just like you normally do. 580,000 and 45,000. Just multiply them out. Yes, sir? Emergency. Let me know when it is. Okay. So go ahead and multiply that out, and good luck. And there are many ways you can do it, so it's not like there's only one way to do it. But go ahead and try it out to see what you get. What do you think? Number's going to be big or small? Big. Big. You're multiplying a big number times a big number. You tend to get even bigger numbers. So that's multiplication there for you. And then you got to be really careful because some of your answers will be super close. You'll only be 10 times too big or 10 times too small or more than that, which I guess is not that big of a deal, right? Okay, I'll give you maybe 30 seconds to work that out. Bless you. Okay, today's lesson is multiply and divide scientific notation. So are these numbers in scientific notation? No, so we haven't even gone through that. I want you to work this one out, and then hopefully that helps you see the value of what I'm going to do next. What did I do? Yeah, notice these numbers, anything special about them? They're the same numbers as the ones you worked out? Okay. I'm going to work it out not the way you worked it out necessarily yet. I'm going to work it out using scientific notation, and maybe we can see, is it easier or is it more difficult? We've got to find that out. Yes, sir?
I think I did it, and I think I know how you did it, because I got the relative same number.
Uh-huh.
But you added two exponents?
Yeah, we're going to get to that. Thank you, Alex. So you're thinking about it, which is good. Let me ask you this. All right, is this the first number? Okay, is this the second number? Are we good with scientific notation? Because if we wrote it wrong, it's going to throw us off. Okay, and then let me ask you this. What's going on between these two numbers? What operation? Multiplication. Between these two numbers? Between this and this. So do you guys realize you're multiplying all four of those numbers together? And what property says you're allowed to just kind of swap them around as you like when you're multiplying? Not distributive property, but the commutative property. So I can rearrange the order of these numbers and still get the same product. So this is what I'm going to do. I'm going to group together, which is technically associative property. I'm going to group together 5.8 and 4.5. And then I'm going to group together 10 to the 5th times 10 to the 5th. So you see I just rearranged and then grouped. So I use the commutative property to rearrange. And then grouping them differently is associative property. Okay, great. That's cool, Mr. A. Good. You can do that. Let's go ahead and multiply these two numbers together. 5.8 by 4.5. So I get 40, 29, 0, 32, 23, 0, 11, 6. Ooh, not 3. 2. All right, and then where does the decimal point go? Between the 6 and the 1. Okay, so I get 26.1. That's if I multiply 5.8 and 4.5. You guys good on that? Okay, and then Alex brought up something from last chapter. You got to be kidding me. That's like in our past. 10 to the 5th times 10 to the 5th. She has the answer.
There will be an optional volleyball practice after school today from 3 to 4:30, and the parents have all been notified. Thank you.
Okay, so there's your, if you're on the volleyball team. Okay, but 10 to the 5th times 10 to the 5th. Are we multiplying two numbers with the same base?
Yes.
What do we do with those exponents? So you get times 10 to the 10th. Good. But there's something about my answer that's just a little bit off. Yesterday, we looked at proper scientific notation, and somebody tell me if this is proper scientific notation or not? Looks pretty good to me. Alex has an answer, but I need someone else to help me out. Drew, what do you think? What's wrong with it? Or is it good?
It's not, the number's not between 1 and 10.
Is A between 1 and 10? No. But I do have 10 to the 10th power, and 10 is an integer, so everything else is good except for this number right here. Now, please listen carefully because you're going to have to do this, and people get this mixed up all the time. Okay, where does this decimal point need to go so that it is in between? Yeah, it needs to go right here. I'll put an arrow here. So it should be 2.61. But when I move my decimal point, I have to change the exponent. So my options are, well, first of all, how many times did I move it?
Once.
So either I make this 11 or I make it 9 because that changes it by 1. So which one is it going to be? Let me answer that question. 26.1. Was that a big or small number? 26.1. It was a big number. So when I moved the decimal once, did I go positive 1 on the exponent or negative 1 on the exponent?
Negative.
Positive 1. Because this was a big number, positive exponent. So that adds 1 to 10, which gives me 10 to the 11th. That is proper. We're going to go through that process. If you didn't get that, it's okay. But that's my answer. Can somebody help me out with standard notation? Because I want to write this in standard notation. Darius, go ahead. Where do I move the decimal point?
Oh, you moved it 11 times.
Which way?
Right.
I thought to the left. Why to the right is basically what I'm asking.
It makes it a bigger number.
I want a big number. 1, 2. Put my decimal point, fill in the spots with zeros. I'll put commas so I see where I'm at. Okay. I'm just going to write that. I know you can write neater, but this is what I'm going to do. What's your answer up here? Somebody tell me. Philip, what'd you get for this problem? Just say the digits.
261 0 0 0 2 3 0 0 0 0 0 0.
A lot of zeros. Commas okay? Okay, how many of you got that when you multiply it out? Okay, good. When you multiply this out, right? Right, good. Okay. How many of you would say, I got it, but it could be a little bit harder to keep track of all those zeros? If you're honest, the zeros, if I put 1 extra or I didn't put enough, this whole answer gets skewed or it becomes incorrect. So this is the answer. And this is the answer. Are they the same thing?
Yep.
So you need to be able to do in scientific notation, and then you can get it to standard form, which we would have gotten 2, 6, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, comma, comma, comma. Okay, so you see how you would have gotten the same answer? Okay, now maybe some of you are saying, Mr. A, the first problem was so easy. Like, I could do that in my head. Or I could do it on paper quickly. Okay, some of them are nice, but some of them are not so nice.
Oh man, this is just really easy.
All right, go ahead and try this one out. You can either convert, well, these are technically your options. You can convert them both into standard form numbers, or you can just multiply them the way they are. So what I'm going to do is this. I'm going to group the decimals together, and then the powers of 10 together, and then get my products. So I'm going to do 2.3 times 3.1, and then 10 to the 4th times 10 to the 9th. Okay. Am I allowed to do that?
Yes.
Just move them around and group them together differently. Tell me what two properties I used.
Commutative
and associative. So am I allowed to do that? Of course, and you are too. So now all you're going to do is 2.3 times 3.1. By the way, when you're multiplying decimals, do you have to line up the points?
Yes. No.
When you're multiplying decimals, no. Do they happen in the last two problems? Yes, they happen. They don't have to. So get my 3, 2, 0, 9, 6, 3, 11, 7. Decimal point goes between the 7 and the 1. So I got 7.13 times 10. How do I get that exponent there? How do I get that, Jack?
You add the two exponents together.
Well, how can you do that?
4 plus 9.
I know, but how can you just add them? I mean, they're being multiplied. Okay, I need an explanation. Yes, ma'am?
They have the same base?
Okay, the same base is being multiplied, so therefore you can add. I'm picky about stuff, Jack. Sorry. Okay, is this, though, my proper answer?
Yes.
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 Henry, is this a number between 1 and 10?
Yes.
Okay, that's good. Are we multiplying by a power of 10?
Yes.
Henry, is that an integer?
Yes.
So this is proper. Good, that's it. Now, I want you guys to do me a big favor, because you're going to have to do it on your homework anyway. Write this number in standard form. Write your answer in standard form.
So like
Just how you normally see it. Yep, with all those zeros. Yes, ma'am?
I'm still really confused on like which way you go.
After this, like from here to the next step, you have two options, right? You can either go right or you can go left. If I move it to the left, I'm going to get some really, really small number, right?
Yes.
If I move it to the right, I'm going to get a really, really big number. So how do I know which way to go? Well, what does that tell me? The 13. It's got to be a big number. So it's got to go to the right. So I'm going to go 1, 2, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to point something out here because how many of you got 71,300,000,000,000? Is that a big number?
No. It's smaller than 1.
Is that how many? It's really tiny?
Yes.
So I can give you that many problems, it'd be pretty easy?
No, well, if we could move the decimal point over again.
Gotcha. I'll move it a couple times. Okay, anyway, do you see how a big number times a big number, and what does that get you? A really big number. Yes, a bigger number. Good, good. Can I tell you this right now? Could you have multiplied these from their standard form numbers? Of course you can. But if you miss one of these zeros, you just got a number that's 10 times less than the actual answer. Or you miss a couple of them, 100 times less than the answer. That's not a big deal, though, is it?
It is.
Oh, okay. Yeah, it's just 100 times less or 100 times bigger. Okay. Go ahead and try this one out on your own. Go ahead and try this one out.
Oh my gosh.
All right, get to work. So I'm multiplying, a small number by a big number. You may begin. How do I do this? Do you have to line up the decimal places when you're multiplying? No. Okay, I got 45.6 so far. And then times 10 to Sam, what power?
7.
Wait, 7?
Negative plus positive, you subtract instead of add, so that gives you 7. And then you take the bigger sign, or the bigger number.
You know what's cool about this? There's another student in the other class. They're like, Mr. A, he said today, when he was working on homework, this is the first lesson I actually, I'm getting. Like the last 2 lessons, I'm actually getting them. I said, oh, that's kind of cool, but can I give you a little bit of encouragement? And this is to all of you. How many of you think you're starting to get this and maybe you'll pretty much pick it up? And yesterday, how do you feel about that one? Pretty good about that one. And if you're not good, you're getting there. Now, in this lesson, there are actually 3 chapter 1 lessons. Do you guys remember when I first introduced this? We're a little confused on what to do here. Okay? Do you guys remember that we talked about this? And some of you still struggled with multiplying decimals. And then we had the properties. That was another lesson. And then I'm going to talk about a couple other things. Guys, you're taking 4 lessons from chapter 1 that you didn't get, and you're applying them to one lesson here, and you are getting it. Because what does it take to get better in math? Practice. And as you do more and more work, you get better and better at it. Yep.
Okay, so
Oh, yes.
It 10 to the 7th power because 12 minus 5 is 7.
Mm-hmm. Okay, but is this my answer?
No.
Hudson, what do you think?
Yes.
Okay, it looks good, doesn't it? Wait. I did I multiply that right? Yeah, I did. So what's wrong with it?
It's too big.
This number, which is called my A number, is not in between 1 and 10. So, Matthew, where do I have to move it?
To the 4.
Right here, between the 4 and the 5. Good. And I'll put a little arrow there. So I should get 4.56 times 10. If I moved it once and it was a big number, what happens to that exponent? Goes up 1 to 8. So it should be 4.56 times 10 to the 8th. Do you remember how I talked about big and small numbers? Okay, 45.6 is big or small? Big. So that means when I move it to make it proper scientific notation, I moved it once, that's a positive 1. And 7 plus 1 is 8. All right, good on that? Great. Dun, dun, dun. This lesson was titled Multiply and Divide. So we're in the second part of our lesson here, and it's very similar. And I'm going to tie back things that you've been doing since 5th grade. And hopefully you're like, whoa, I didn't know I was doing that. Maybe you'll get to that point. Okay, notice these 2 numbers here. The top number, is that proper scientific notation?
Yes.
Yes, but the bottom one, oh, that's standard form. Can I make it scientific? Go ahead and do that real quick. That's a review of yesterday's lesson. Make 510,000 into scientific notation, because that's going to help you to start working this problem out. And I'll go with Mary. What would this be in scientific notation? Sorry. Go ahead. I'll give you some time. Go ahead and get that down, guys, and then I'll tell you what we're doing on this problem. And again, guys, is that a big or small number? 510,000. Big number, which means what kind of exponent should 10 have? Positive, like automatically positive. So, Mary, how about this? I'll write it down. You tell me if it's right or wrong, okay? Is that right so far? Yes. Okay, good. Ready? Mary? No. What? What happened? Yep, how many times? 5 times. Positive 5. Oops, yeah. It's one off. It's funny, my son, when I say what, I kind of remind myself of my son Ezra, 3-year-old. Whenever he hears something that's like out of the ordinary, he goes, what? What? And it's usually a good thing. Like, okay, Ezra, you know what we're going to do today? We're going to go to the park, and then we're going to go see your cousin Noah. So he really likes his cousin. What? I'm like, yeah, it's good, right? But he gives me that, like, what? Like, unbelievable word. So I remind myself when I talk of my son Ezra, which is kind of weird. Anyway, how many of you got this right here? How many got this right here? Okay, now this is what we're going to do. What's going on between the 2.61 and the 10 to the 11th? Multiplication. What's going on between the 5.1 and 10 to the 5th? What's going on between these 2 numbers, though? Division. Okay, so it's not, I'm not going to just commutative property, move things around, jumble them up, but I am going to understand this, that I can break this down into 2 fractions. 2.61 over 5.1 times 10 to the 11th over 10 to the 5th. Just write that down and you're like, Mr. A, how can you do that? I'll show you how you can do it, and I'll show you how you did it. You have done it for at least 2 years. At least 2 years, maybe more. It just depends. All right, is that possible? Am I allowed to do that? Just separate it, call it multiplication?
Yes.
Answer is yes, and I'll show you how you've done it. Okay, let's deal with fractions. Let's go with 2/7 times 3/5. Okay, 2/7 times 3/5. Is there anything to cancel out? No. So why don't we just get, look what I'm going to put. 2 times 3 up top and 7 times 5 down low. I mean, is that what I get? And then you simplify those out. Did you get that? No. What's 2 times 3? I'm just saying 2 times 3, 7 times 5. Okay, this right here has multiplication up top and on the bottom, and what's going on between those two parts? Do you guys see it? Multiplication, division. So could I rewrite this into this? And the answer is yes? Okay. You can. If you didn't get that, it's okay, but I'm not making things up. I'm not trying to I'm just going to split it up. We have been doing that when you work this way, but you can also work that way. You can go backwards on that. And we're going to get more into that later on. I'm allowed to do this. So now, what am I going to do? We're just going to divide. Which one goes in the box? 2.61. I thought it's the bigger number. It's always a number on always. Like you could take that no matter where you go. It's always the top. Goes in the box. Okay, but can I divide by a decimal number? No, move it over once. I'm going to put it right here. Bring the decimal in my quotient. 51 goes into 26, no times. 51 goes into 261, 5 times. That's 255. Subtract those two, I get 6. I'm done here? No. What do? Add a 0. 0 comes up. Wait. I'll leave it like that. 51 goes into 60 once. Running out of space. 60 minus 51. 9, and then I bring down another 0, so I have 90. It's going to go into it. I have a problem here. Confession to make. This number keeps going for a while. Okay, so it's not going to repeat. What's going to happen is it's going to keep going, but none of your homework problems are going to do that. Okay, so what I'm going to do on this problem is I'm going to round it to 0.512. So 0.512. So that's the division part. Again, yours is going to come out nice and clean, so that's nice. Enjoy that. But what's going on right here?
No.
So, yeah, you do 10 to the 11 minus 5, which is 6. 10 to the 6th. Oh. Is that proper scientific notation?
Yes.
No.
Yeah, this number has to be between 1 and 5. So where do I have to move the decimal? Once right here, I get 5.12 times 10. Now listen carefully before we give answers. Was this a big or a small number to start with? Small. I moved it once over, so that's a -1. 6 plus a -1?
5.
This goes down to 10 to the 5th. Yeah.
Didn't you move it twice?
Just once, right?
Round
Oh, I didn't round exponents. These are.
because you moved it over.
I moved it over again. So listen carefully, guys. We're going to do a couple things in this lesson. We're going to divide decimals, multiply decimals. We're going to divide powers of 10, multiply powers of 10, and then we're going to have to correct into proper scientific notation. So this is very important. Okay. Do this one. You're like, oh my goodness. Mr. A, you're evil. Why do you do this? Is that allowed?
Yep.
No.
Yes.
It is. It's so very loud.
Okay. So, oh, man. Sorry guys, 7.5. Goes in the box. Divide by, oh, come on. I don't know how many times 2.5 goes in 7.5.
3.
Oh, okay. 3 times. Mr. A, that was impossible. A lot of you already did it. Very quickly. Again. Hold on. First, did we get 3? Dividing these out, we get 3? Times 10. So we get 8 minus 9 is negative first. Okay. Jackson, is this proper scientific notation?
Yeah, no.
Hold on, Jackson. Yes or no?
Yes.
You sure? Okay, I'm going to ask you a few questions. Is this a number between 1 and 10?
Yes.
Okay, so far so good. Is this a power of 10?
Yes.
Are they being multiplied?
Yes.
That is an integer?
Yes.
I thought integers were whole numbers. Jackson, I thought...
And they're opposites.
And they're opposites. Okay, now, you know what I did with Jackson? Thank you for being so willing. I made him think about every part of the scientific notation, and we even went back to lesson 1-2 or 1, I forget which one, integers. Do you guys even know what an integer is?
Yes.
And you're like, Mr. A, why do we have to go over this? It's because I want Jackson now, on the next problem, when he's working it out, to not be like, I hope that's right. No, he's asking those same questions quickly, and he gets it, and he's done. So 3 times 10 to the negative first. Natalie, big or small number?
Small.
Really? How do you know that, Darius?
The negative exponent.
Good. That's how you know it. Small number. And is it super, super small? No. It's only to the negative first, which is 0.3. Good. How many of you guys are okay with this? Yes, ma'am?
So I was confused why you subtracted 9 from 8.
Yeah, because when you are dividing 2 powers of 10,
Oh, okay.
you subtract the exponents. Yep. And that's the rule from 1-11, I think was the lesson. Last one. I want you to multiply these 2 numbers out, but
Scientific notation.
I don't want it standard way.
You want it scientific?
I want scientific. So do it scientific
But standard.
notation. Sorry?
But just scientific.
Just scientific notation. That's all I want to hear. So these are in standard form. I need you to write them scientific, then multiply them, then get it. Make sure it's correct. Then you can do well with that. Okay, I'm going to start just asking people questions here, so please pay attention. Hudson, what's 35,000 in scientific notation?
3.5 times
10 to the 4th. Great. Brad, what's 9,600 in scientific notation?
9.6 times 10 to the 3rd.
Good. So you see how this is review from yesterday? So you're just converting. And then today, how do I combine these 2 together? So what do I do first, Matthew?
You do 3.5 times 1.6.
Okay, so I'm going to multiply these out. And where does that decimal place go, Lana? Where do you think it goes here?
After the...
And you can tell me between this and that, because that might make it clear for me.
between the 3 and the other 3. Wait, sorry.
That's okay. So I have 2 decimal places. I move it twice to the left. So it goes in between the 3 and the 6. Yep. Okay, so I got 33.6. And Hagen times 10 to what power?
To the 4th plus 3.
Which gives me a total of 10 to the
10 to the 7th.
10 to the 7th. Yay! Eva, what's my answer? Oh wait, I have it up here. I'm so sorry. That's
33 is in between 1 and 10.
oh. Gotcha. All right. Picky, but that's okay. All right, Sam, I moved it once to the left, so it became 3.36. Oh, yeah, that is between 1 and 10. I gotcha. Times 10 to what power?
8.
8th power. That is proper scientific notation. Okay, listen carefully to the instructions for the homework. You're going to do problems like these. Sometimes they're in standard, sometimes scientific. You get them into what they say to do. So listen carefully. Sometimes they say write your answer in scientific notation. So you write it this way. Sometimes they'll say write in scientific and standard. So what does that mean? This way and the normal way, which is going to give you 2 answers.
Wait, how do I get standard?
From that? Really? No, you sure? I'll go through it. All right, here's your homework. Boom. Goodbye, Swivel.